Just like what I'd like to have a look at the process here in Building 58, the Tektronix Video Networking Division. The process is probably one of the best that I've ever seen, and I want to just document it before it gets dismantled. This is the entrance to the factory floor and all of the processes, and it's about 50,000 square foot, and it also contains factory service in the same footprint, which is very unique. But this is just some of the products that we built here. Network displays, which we sold to network computing devices in California, and now we're going to be transferring the profile business group down to Grass Valley. And the Videotele.com group will go to the measurement division. Just a little close-up on an Emmy that the division won, and just one of the many awards I think that we've gotten out of the NAB type shows and so forth. At the height of our business, okay, VND Manufacturing was located in the Pacific, Europe, and here in America. And we had locations globally. Beaverton, Oregon, Grass Valley, California, Madison, Wisconsin, London, UK, Heerenveen in the Netherlands, Sydney, Australia, and Bangalore, India. So this was when we were approximately a $400 million piece of the Tektronix business segment. Just one of the many things that make this whole process work so beautifully is a very simple daily behavior process of meeting at 8:15 each morning with all of manufacturing and the support groups to go over the day's issues, priorities, status, and a very simple system with 3 lights that anyone in the organization is empowered to turn on to identify a potential quality problem or other types of problems that may be occurring in the process itself. Once the lights are turned on, groups are gathered and resolved. That's with engineering, service support group, materials, new product introduction, and so forth. The daily status is on the board. We do track our critical material that may or may impact our production. And what we actually do is each week share the coordination of the meeting with individuals out of manufacturing and support groups. The agenda is very simple. We keep it to 10 to 15 minutes, and we walk down through our quality, our printed circuit board assembly status, the final assembly status for our products, the parts situation, the orders, what kind of orders are coming in, what kind of priorities, mods, which are another word for engineering change orders, any kind of new product introduction issues, and the ESD check to make sure that we're all in compliance with the ISO 9001 standard. So everyone meets here 8:15 and has a real good pulse on the business. Our process starts with the printed circuit board assembly line, which is continuous flow, and it's very unique with no setups, direct line. From start to finish of a board is less than 1 hour, and I have personally seen us run 20 different boards back to back in a given workday. Taking a look at the line, it's continuous flow, starting basically with the paste, and the unique process here is that the flats are all of one size, so everything fits in so that there's no changeover, no setups, and everything can just be run back to back, and it's actually pulled like a Kanban system. Each station, as it completes, will allow the next board to come in behind it. Everything is programmed here in-house, and we do all of our new product introduction activities, checkout, prototypes, and so forth. The high-speed placement machine, plus all the other auto insertion machines, are stocked with material on feeders and reels that never come off the machine, so there's no setup on material. So material stays on the units at all times. This particular process has been in place for over 3 years, but we did add in the last 15 months the new high-speed placement unit that basically is capable of doing a very fast job, and it has about 29,000 parts per hour capability with 240 feeder slots, and again, nothing does come off. Now, it's very unique because we do run both-sided, two-sided boards on this line, and prior to this machine, we were not able to do that, just single-sided. So basically, what we've done with process engineering is that they've developed what I call a flipper. So if it's a single-side board, it just goes through the oven as a conveyor and just moves on to being finished. If it is a double-sided, it goes through the oven and then flips here over on its other side to be completed later. So there's no stop in the flow. It's literally continuous flow, and continues to be completed back through its programming. And what's a very unique also process is that across the aisle we have the supplier material for about 35 to 40% of our material in stock, where the suppliers own that material. It's called a supplier integration program. Now, we do not start the accounts payable clock on any of that material until we've actually used it at the end of this line and decremented the usage into the procurement system. So again, everything is continuously flowing. We have breakout conveyors where we can walk through the line without walking around. And again, each of the machines are requesting the board behind it when it's finished. So it's an automatic Kanban process of pull. Now at this particular time, 1 to 2 people can run this line non-stop, so very low labor, very high quality. We have our own maintenance technicians that maintain the material. We have the fine pitch placement machine, which is doing our processors and so forth. We do use ball grid array, and this way we can keep our lots to a very small number of runs. So if we do have a defect in the process, we can catch it very easily. At this station is our first visual. We will take the first couple of runs and make sure that the parts are being placed precisely correct. And at this point, the paste is not yet set up. We have not permanently soldered. So we can make any kind of adjustments that we feel necessary and do. We also have a buddy system where if we do replace a part on the line, two people, two pairs of eyes check that to make sure that part number is correct, so we don't get any incorrect components in our process. Now, when it goes through its final wave here, then it comes in at the end of this line. Okay, we have our manufacturing execution system, factory automation, called Simple, C-I-M-P-L-E. And what Simple will do at this point is it will do several things. The operator will barcode the assembly, and it will then be downgraded on all of its material. So procurement sees exactly what we have consumed, and we at that point then will start the accounts payable clock. Also, it will start recording this particular assembly for the rest of its journey through its entire life. Any kind of defects it may have, when it was built, its part number, its revision level, and so forth. Now again, Simple is quite fine-tuned into bringing up automatically the actual new or the procedures affecting any kind of hand add. Now at this particular station, which is very small, we've done a very good job in concurrent engineering on reducing the amounts of hand add, so that you can see this is the entire contents of the hand adds on one table. One operator can do it, and the procedures will automatically come out to identify to the operator how to perform these functions. Now at the time of hand add, it'll go through its final wave solder for the through-hole components and become a permanent module at that point to go into our product. Now right across from the wave solder, the assemblies now will come out of the oven and come down through in preparation for a D-tab. And D-tab will just simply make those then modules and discard the remainder. At this station also, any kind of tape removal or slight modification or engineering change order may come on, but it's first tested here. And it's tested, okay, at these two stations to identify if it is functionally, at least electronically alive and connected together. Now, at this point, it takes one little slight turn, and it is what we call a quick test operation. Now, the quick test, all it's doing is saying, hey, I'm ready to pass on into module test, and at this way, if we see any kind of a trend or anything like this, we can stop immediately. We've only got a few boards in behind it in the process, so everything can be stopped quickly and prevent defects. All right, now as we move down through the process, we'll go into then module test. Now module test is another functional diagnostic type test that will test each module. Now, just down here from me is the halt chamber, which is the highly accelerated life test and stress test that we put our OEM components and our own product to verify our process in. This particular unit will be going over to MBD, but it has been very useful in qualifying supplier provided materials such as power supplies, disk drives, and even our own process. We do our own repairs, and on boards we have a ball grid array removal machine where we can actually go down and remove the components, repair them quickly, and salvage them going on. Now, one thing in our material requirements planning system, any kind of a module that goes into a reject area is then tracked and is nettable, so we do not build up lots of inventory. Now, module test, okay, when it enters this particular section, we have a philosophy called KGM, and that is known good module. At this point then, each module is fully tested, and it's tested in a test station, and right across from the test operator is the technician for any kind of failure analysis or troubleshooting. So then you can see in an open fixture how each one is tested with its own diagnostics, and this way we have a very high yield at final assembly and systems test where we do not want to have much fallout. But we currently have 5 stations here on the profile line, and each one then is across from a technician station, and these individuals are experts in their particular module area, and they will then perform their particular functions, and if there's any trend at this particular point with either a bad lock code from the supplier, something other than that, workmanship, we can stop the line immediately and only have a few boards to back up and repair. We also utilize these particular technicians to do a lot of the debug in our new product introduction time periods for all the new products coming down. Now, the concept is very simple. Okay, at this particular section you can see on my right are the test operators, on my left are the technicians. The test operators is the is the customer and the supplier sitting over here in the technician area, ready to make sure that that particular board gets all of the necessary analysis if indeed it has a problem. So the microfeedback's immediate. It's right across the aisle. All inventory is visible. There's no build-up in back rooms. Very easy to walk the floor to see exactly where we are, what's being worked on, and keeping the inventory very low. Now at this particular time we enter what we call the invisible firewall. And across from this section is we call our mixed video product line, MVP. And we then process all of our video products down through this for the server and its peripherals from this point. Now also disk drives, which are installed inside the chassis, are also in a bonded little warehouse here owned by the supplier, and we don't take possession of that until we actually use the disk drives. So in final assembly, today we have the PDR 200, 300, have introduced the 400, which is the DVC Pro, and we are going to be introducing and doing a beta on a Keystone product, next generation of family for the profile server area, and we'll be introducing that here in the next couple of months and then sending it off into Grass Valley. Now at this point we have a daily build rate. Everything's synchronized all the way back through the modules for printed circuit board assemblies, and on the daily feed we receive our chassis partially complete by a local supplier, Nielsen Manufacturing in Salem, with a Kanban cart on wheels. So literally we just rotate this cart back and forth daily and receiving a flow of material into our process. Now at this point, currently our daily rate's 6 per day. We have a capacity to do up to 12, and with overtime even 16 a day. But at this point 6 a day are then being built at this particular area, and will be configured going down the line. Now this flow is a direct flow, no backup. We call it a superhighway. And as we get into this section here, this is what we call power up. Now power up, or codename PUP, is about a 45-minute process where everything is hooked up to video, make sure everything is functioning with the known good modules, all of its components, and from here it will reside for a 24-hour period in a run-in or burn-in chamber, which is right across from me. You can see above the monitors, and in that particular area it will go through record, play all of its video diagnostics for 24 hours, calling that burn-in. Now at the burn-in, then it will get a complete actually go through as far as all of its functions and what's happening. Now here we can have about 50 products at one time in both sides of this bay. We have had it full, and it ends into quarters, it's empty. This last quarter just ended here in May of '99. We did not have one profile left in the burn-in bays. But this way, all of it is assisted by automatic mechanical lifting equipment. Literally from the time a product is built to the time it is shipped, no one has to move anything. It is moved down these rollers and on into shipping and out the door. So very short and very straight line. Now on this side of the section is our video network area that we are selling to network computer devices. It is a higher volume line, very automated, again with the simple factory automation tools, and the daily rates here are quite high, but the unit prices are much lower. Now you can see here we're doing some engineering quality verification. These happen to be RAID units from Clarion, which is our OEM supplier, and they are being tested here, hooked up with the video servers in the bay for engineering new product valuation. Now at this particular stations, coming out of the burn-in area, it goes into what we call a customer ordering process configuration straight across from me. This is about a 45-minute operation, and it's configured now either to the customer options, or if it's a Kanban, which we call, it's a basic machine still waiting for customer orders for population and final configuration. But at this particular point, these 4 stations perform an in-depth, completely automated procedure and process that will take it through all of its specifications and reacts actually to a customer environment, as the video server is going to be in application in the major broadcasting or video markets. Some of our major customers are CBS, NBC, Fox, HBO, and various other companies. So at this point, each one's getting a thorough run-through prior to it. Now, there is a low-cost new product called the Pro Series, and this is for adjacent markets that really attack the less than the top tier, or like the NBC kind of broadcasting networks. And these we are selling through distribution to markets such as racetracks and casinos, and people that want to have the video storage digital with the disc without spending the money for a profile. Okay, now as we move down through, the senior systems technicians then will ready it for a final QC. Now, at final QC, it runs through one last run through. We call it button up before it's actually gone into shipping. And at this point, it has passed all of its specifications from each module, each component, all the way to its functionality and its software applications. Now, Simple has recorded each one of these units, all of its modules, and all of its quality data. So if for any reason we have a problem, we can actually go back and we do root causes, we do Paretos, and the yield at this point is quite high coming through this process. So as you look back, you can see that as we turned from the making of a module through the entire assembly process, it's very straight line and very automated. Labor here is very low content of our particular product. Now down on my right, you can see the network display area where we do our final shipping, and with that we will use Simple as well, and Simple will track then each shipment through into finished goods and out to the customer. Now as we turn here on our process, there is a function we perform that's very important to us, and it's within our manufacturing engineering group under product assurance, and this function is product audit. Now, product audit, we will randomly select each day out of the box a product, and we will perform a customer application and install process to verify total 100% quality. Now at this particular area, we're looking for both functional problems, workmanship, cosmetics, anything that we feel is not up to 100% standards in the quality area. Now as we find any kind of issues here, this will be reported each morning at the 8:15 meeting area and rapidly root caused and corrected. We can produce a CLCA, or closed loop corrective action document, on items that are worthy of control in the ISO system. But both our products and our OEM peripherals are definitely checked out. This area also does a lot of the final quality audits for the OEM at the end of the month. And you can see here's some of our products coming in from Clarion. They are the RAID units. They'll be quality tested and then shipped. Now at this particular area is the final leg of our journey, and this is the shipping. Also tied into simple. The entire area, 70 stations, are tied into simple. The products now will come straight down, you can see on our highway, and that's coming out of the COP, out of the Customer Verification Systems testing area, and the final QC stations, and then will be prepared for shipment with all of its accessories. And again, as the simple packing list is provided and completed, the simple system will tell the operator if they are missing anything, have packed too many things, put something in there that didn't need to go, and then produce a packing slip, and then we pack and ship on to finished goods. And at this point you can, I'll just show you a little bit of our shipping. Is very robust. It's on pallets, so I've been here 2.5 years, and I seriously have not been aware of one damage due to mishandling. And you can just see what this area does a little bit, but we've had almost no incident of missing parts, so it's a very high quality process. Now if you look back on this, and I've tracked it from the start of fiberglass on a printed circuit board assembly to the shipping of a product here is 145 paces. You won't find that in very many processes, at least that I'm aware of. So it's a very high quality, low labor, very much value added. We're trying to remove any non-value added from our process. Right across the aisle, okay, is our factory service, which worldwide repairs all of our products, and it also is moving to Grass Valley operations. But this provides then a immediate feedback to our factory personnel as to any kind of trends being seen in the customer base, and also we can utilize our skill sets back and forth, cross-functional. The technicians here in this area can be brought up on new products before they're shipped, so by the time they are received in the customer installation area, we definitely are up on the processes. Also keeps inventory down low, because we can provide material right from our line instead of having stock rooms and costly inventory overhead. So that again is a real good attribute. But once again, this is the first highway. At the end, you will see it make a jog to your right and then finishes right around the other side and out the door. So just wanted to document this. It runs tremendous, very, very effective, and I just think we should learn from all the things that a lot of hard-working people and smart people have put together, and not forget it. It's one of those things that I think we can all take these learnings and share them wherever our new journeys are going to be. So I hope everyone enjoyed this little reminiscent trip down memory lane. I know I've been very, very proud of our process, and you know, equipment's equipment. You know, what's made this such a very successful and state-of-the-art, world-class process is the methodologies, the philosophies, the concurrent engineering, the continuous improvement, the close communication, the teamwork, the empowerment of our people, and the way we do business. So with that, I will say goodbye, and hopefully we can refer to this as we move on to our new destiny.